Hello everyone, in this video we will be discussing about computer science solved questions of 17 December 2017. It is a part 4 of the videos. In this video we will be discussing about the question 32 to question 40. Let's proceed to the questions. Okay, the first question is we have address and we have to divide this address into two parts. That is, half of the addresses has to be given to organization A and quarter given to organization B. Okay, and the remaining with itself. That is, this is IP address which is given, that is 245.248.128.0/20. This is the IP address which is given. So it is the broadcast ID, BID, network ID of the IP. So number of hosts in this, total number of hosts in this IP address would be 32 minus 20, which is equal to 12. Host ID is 12. So total number of hosts is total number of hosts is 2 to the power 12. 2 to the power 12 would be total number of hosts. So what is the question? The question is, the ISP wants to give half of this chunk of address to organization A. So half of 2 to the power 12 would be given to A. Half of 2 to the power A. So A would contain half of 2 to the power 12 hosts. Okay, and the quarter to organization B. So organization B would contain 1/4 of this 2 to the power 12. Okay, so for organization A, number of hosts will be 2 to the power 11, and for organization B, number of hosts will be 2 to the power 10. Okay, so now we will be calculating the BID, that is network ID. BID for organization A would be 32 minus 11, and similarly for organization B, the BID would be 32 minus 10. That is, for A it is 21 and for B it is 22. So what would be doing is, this is the IP address which is given. In this address we would be taking the first 21 bit as a network ID. Okay, so in this, the first 20 bit would be same as it was there, and the 21st bit can be either 0 or 1. So how would we be writing is, we will be writing it as 245.248.128.0. It is the question, so I'll be converting it to binary. So it would be 245.248. For 128, I will be writing it as 7 times 0. 1, 2, 3, 4, 5, 6, 7 times 0. It is 128 and rest is 0. Okay, I'll writing it as like this only. Here also I would be writing it like that only. That is 245.248.128.0. I'll be changing it 245.248.1 7 times 0, 7, and it is 0. It is 8 times 0. So see, we would be first 21 bit would be considering. So it is first 8, it is 16, and first 20 bit would be same, because in this it is /20. So first 20 bit, it is 16, 17, 18, 19, 20. These bits would be same for this also, and here also the first 20 bit would be same. First 20 bit would be same. In the 21st bit here, it can be either 0 or 1. Okay, and here the 21st and the 22nd bit, 21st and 22nd bit, it can be 00, 01, 10 or 11. It can be either of them. Now let's move on to the answers first. In this, for the BID for network A is /21. And for network B it is /22. So we would see in the options. So it is, for A it is /21, A it is /21, for B it is /22, for B it is /22. That means either option A or B would be right. Option C and D is not right. Okay, because for A we are having 21 here, and B we are having 22 here. So similarly A 21, B 22. And let's move on to the address. Okay, let's see. If I change, see, here it is 128 in both of them, it is 128. That means out of these four options, that is 00, 01, 10 and 11, the 00 option is considered. Okay, that is, the option is here is 00. 0 0. Okay, so if B contains 0, then if in B the both bit is 0, so that means for A that bit has to be 1. This bit has to be 1, it cannot be 0. So our final answer for A is 245.248.1, 1, 2, 3, 4, 20 bits over, and this 0 would be 1. It is 1, 1, 2, 3.0. When we change it to decimal notation, it is 245.248. It would be 136.0 slash 21, and this would be 245.248.128.0 slash 22. So this is our answer, that is answer A. A is our answer. Okay, this is our question. Next question. Assume the source and destinations are connected through an intermediate router. Okay, how many times we have a source, let it be source, and we have a destination, let it be the destination, and both source and destination are connected through a router R, let it be R. Okay, how many times a packet has to visit a network layer and the data link layer during transmission from S to D? We have to transfer this packet from S to D. This packet has to be transferred from S to D. So see, router is a network layer device, so it would be containing only 3 layers, that is physical layer, data link layer and network layer. Now if a packet has to be transferred from the source to destination, so let's see, this is the packet, so we have to count the network layer and the data link layer. Okay, so this packet would travel here, so network layer 1 times, data link layer 1 times. Okay, from the physical layer it would go here network layer 1 time, sorry, physical layer, network layer 1, data link layer 1 time, and it would go like this, network layer 1 time. Okay, then it would come like this, here data link layer 1 time, it would go like this, here it is data link layer 1 time, here it would go like this, it is network layer 1 time, and it would reach the destination. So see, network layer is 1, 2 and 3. So 3 times network layer, it is option D. Let's see for the data link layer it is 1, it is 2, it is 3 and it is 4. 3 times network layer and 4 times data link layer. D is our option, it is our answer. Okay, because router is a network layer device, it is a network layer device. Okay, next. Generally TCP is reliable and UDP is not reliable. Yes, it is true. DNS, which has to be reliable, uses UDP because, okay, the main reason that DNS uses UDP is faster than TCP. It is not slower. UDP is faster because TCP uses 3-way handshaking. But that's why UDP is faster. There is no handshaking no connection establishment in UDP. So UDP is faster. The first option is, it's false. Okay. Second, DNS server has to keep connections. No, DNS server don't have to keep connections. So this is also false. And DNS requests are generally very small and they fit well within UDP segments. Yes, this is true. And the UDP is also unreliable, but the reliability can be achieved in application layer. Okay, so this is true. The answer C is true. Answer C is true for our question. Okay, answer C is true. Okay, and DNS server, they don't have to keep any connections. Don't have to keep any connections. Don't have to. You have to remember this. Questions can be asked in different types also. Okay, this is the answer. Next, consider a set of activities related to email. Okay, that is sending an email from a client to email server, downloading the email. Okay, so for sending an email to an email server, we can use SMTP or SMTPS. Okay, for downloading the email, you can use IMAP or POP or POP3. These are the protocols. Okay, for checking the email through a web browser, you can use HTTP and HTTPS. Okay, these are the protocols which are used. Now let's check. It is SMTP is there. So first is SMTP, Second is either IMAP or POP. So IMAP is over here, POP is over here, so either two of them. And third is HTTP. So here it is not HTTP, so it is C. C should be our answer. So you have to remember these things, okay? Next, a station uses 32 byte packets. So it is the packet size is 32. So packet size is 32 byte. So 32 into 8, it would be in bits. Okay. Second, to transfer message from station A to station using sliding window protocol, the round trip delay, that is the round trip delay, I'll write it as RTT, is 40 milliseconds. Okay, it is given. And the bottleneck bandwidth from part A to, and the bandwidth is given as 64 kbps. Okay, and it is given as 64 kbps. Okay, and optimal, what is the optimal window size? Okay, so that A should use. So the optimal window size is for which the throughput is maximum. Okay, optimal window size is the window size for which throughput is maximum. Okay, so maximum throughput is the bandwidth. Maximum throughput is bandwidth. It is 64 kbps. It is a maximum throughput because it is the bandwidth of the path. So the formula for throughput is, it is given by 1 into window upon round trip delay. It is given by this. So optimal window would be equal to the maximum throughput into round trip delay. Okay, so maximum throughput is 64 kbps. So Windows optimal window size. Optimal window size is equal to, it would be equal to maximum throughput, that is max throughput into round trip delay time. Okay, so max throughput is 64 kilobytes per second, so I'll be write it as 10 to the power 3. Okay, into round trip delay time is 40 milliseconds, so I'll write it as 40 into 10 to the power minus 3. So I will solve it as, I'll solve it, and it would be like it would be like this. Okay, so we would be having 8 cross 8 into 40. You can write it like this, 8 cross 8 into 40. You can write it like this. Okay, now in terms of packets, it is the window times in terms of bits. In terms of packets, you have to calculate the window size. In terms of packets, it would be, the packet size is 32 into 8. So it is 8 cross 8 into 40 divided by 32 into 8. So 8 1 8 1 8 4, it would be 10. So 10 is our answer. So B should be our answer. A two-way set associative cache memory unit with a capacity of 16 byte. So is built using a block of size 8 words. Block size is given. The word length is 32 bit and the physical address space is 14 GB. Number, tag and set fields you have to calculate. So let us check. We have to first calculate number of sets. So number of set is equal to cache size, okay, upon size of set. So cache memory size is 16 kilobyte. It we all know. And what is the size of set? Size of set is equal to block size, okay, into number of blocks in a set. Okay, so block size, it is given 8 words. Okay, see, cache size is given 16 kilobyte, block size is given 8 words. So I will be returning as 8 words. Okay, 8 words into number of block, it is two-way set associative, so number of blocks would be 2. Okay, so words, one word is equal to 4 bytes. So I would be writing it as 8 into 4 into 2 bytes, which is equal to 64 bytes. Okay, now number of set is equal to cache size upon block size. Block size is 64 bytes. Okay, now this is in kilobyte, this is in byte. We would be converting it as 16 into 1024. Byte would cancel by byte upon 64. By calculating this, we would be having 256, okay, which is equal to 2 to the power 8. It is 2 to the power sets. Okay, so 8 would be the set field. Set field would be 8. So 8 we have here and 8 we have here. So our option D and C, A and D had been cancelled. It can be either B or C. Now let's calculate for the tag field. Okay, now the physical address spaces, what is the physical address space? It is 4 GB. 4 GB is the physical address space, and we have total of 256 sets. So now we would be dividing the physical address equally into 256 sets. How? That is equal to 4 GB upon 256. Okay, so when we would be calculating it, 4 GB, I will be writing as 4 into 1024 into 1024 into 1024 upon 256. When I will calculate it, it would become 16 MB, that is megabyte. 16 megabyte would be my answer. Okay, so it is in terms of bytes. I will be changing it in terms of words. So it would be 16 by 4 mega words. So it would be equal to 4 mega words. Okay, we will be dividing it equally into all this. So now we have 4 mega words. 4 mega words. Okay, each block is of 8 words. So I will be dividing it with 8. So we would be having 1 by 2 mega blocks. Okay, now we will be converting it into bytes. Okay, so it is 1 by 2 mega is written as 1024 into 1024 blocks. So after solving this, we would be having 512 into 1024 blocks. Okay, it is 2 to the power 9 and it is 2 to the power 10. So answer would be 2 to the power 19. So 19 should be the number of blocks. So tag would be 19. So our answer is 19,8. That is B should be our answer. Okay, you can go through this video once again if you have any doubt. Okay, next. 38. A CPU has a 32 KB direct mapped cache with 128 byte block size. Suppose A is a two-dimensional array of size 512 into 512 elements that occupy 8 bytes each. Consider the code segment. Okay, C, this is row major. This is arranged in row major because it is row is fixed and it has column has been changing 0, 1, 2. Okay, so this is row major. So now total miss for this process would be size, okay, into number of array element in each block, block size upon element size. Okay, and this is number of cache blocks is equal to cache size upon block size. So we have to put all the values over here. What is the block size? It is given over here with 128 byte is the block size. So I'll write it as 128 byte is the block size. What is this element size? Which each element occupy 8 byte. So 8 byte is the element size. Okay, which is divided by, we have cache size. What is the cache size? It is 32 KB and block size is 128B. So now we would be solving this, and after solving this, it is 512 into 512 into byte would be cancelled by byte. It is 128 upon 8 into 128 byte upon 32 into 1024 bytes. So byte would be cancelled by byte. So after cancelling and solving all this, you would be having 128 into 128 which would be equal to 16384. So this is answer A. A should be our answer. So see, what the total miss is array size into number of array in each element in each block, number of array element in each block upon number of cache blocks. This is a formula. Okay, and for number of array element in each block is just block size upon element size, and number of cache blocks is cache size upon block size. Okay, so this is a formula. You can solve it like this. Next question. A is the answer. Next question. A computer with 32-bit word uses 2's complement to represent the range of integers can be. Okay, so range of integers we would be discussing for all, for unsigned. Okay, for signed magnitude and for 2's complement. Okay, if n is the number of bit, n bit. For unsigned it is 0 to 2 to the power n minus 1. Okay, for signed it is minus 2 to the power n minus 1 minus 1, 2 plus 2 to the power n minus 1 minus 1. This is for signed. For 2's complement it is minus 2 to the power n minus 1, 2 plus 2 to the power n minus 1 minus 1. That is, if n is equal to 32, we have minus 2 to the power 31 to 2 to the power 31 minus 1. So this is our answer, and this is answer C. Okay, for the theta it is C. Next question. Let m is equal to, we have two binary numbers. What is m and n? 2 digit 8 complement, 2's complement, 8 with 2's complement number, and the product is a 2's complement, and the product would also be a 2's complement number. So let's see. We have m is equal to 1 1 1 1 then 1 1 1 1 and 1 0 1 0. This is n. So it is what? It is 6. It is minus 6. Okay, this is a 2's complement number. It is a 2's complement number. So it would be minus 6, and n is equal to 2 3 4 1 0 1 0. It is 10 in 2's complement. So m cross n would be minus 6 into 10, which would be equal to minus 60 in decimal. Okay, so that we will be converting it into the digital form, form. So in this it would be 0 0 1 1 1 1 0, and it is minus 60. So first bit would be 1. Okay, it would be 1. It is in the binary. So we would be calculating its 1's complement. So all zeros, sign bit would remain same, and all zeros would be converted to 1 and 1's to 0. 1 1 1 2 3 4 and 1. Okay, this is 1's complement. For 2's complement you have to add 1 to this. Okay, so it is 1 plus 1 0, 1 carry, 1 plus 1 0, 1 carry. It would be 1. It would be 0 0 0. It would be 1, and it would be 1. This is a 2's complement. So this is what should be the answer. That is 1 1 3 times 0 1 2 times 0. That is A, I think so. A is the answer. Okay, next. Okay, this was for the part 4. If you like the video, please subscribe and keep watching for further videos. Thank you.